So we're going to take a look at this probability question from the 2012 Leaving Cert Ordinary Level paper. So it's question 2. It's a question about dividing a pack of cards in this Venn diagram. So we can see that we have a section here, a circle that's going to contain clubs, a section here that's going to contain picture cards, and then obviously there's going to be some cards outside of the circles that are neither clubs nor picture cards. The first thing to run through quickly is just what's in a pack of cards. So in a pack of cards, we have 52 cards, so that's told to us in the question, but it doesn't say how the cards are divided up. So we have 2 black suits, clubs and spades, and then we have 2 red suits, hearts and diamonds. And the 52 cards are divided evenly amongst these, so there's 13 cards in each suit. In each suit we have cards ace to 10, so that takes up 10 of the 13 cards, and then we have a jack, we have a queen, and we have a king, and that's the same for all 4 of the suits. So each suit has cards ace to 10 and then a jack, queen and king. So with that knowledge we can now go and maybe start to fill out the Venn diagram. There's 52 cards in the pack, and so it's a good idea when you're doing a Venn diagram to put that number just on the outside of the box here, so that we know in total all 52 cards have to go somewhere in this box. Of the 52 cards, 13 are clubs and 12 are picture cards. So 13 are clubs and we have 12 picture cards. And again, this is just notation for us so that we know that altogether in this circle we need to have 13 cards, and altogether in this circle we need to have 12 cards. Of the 13 clubs, 3 of those clubs are the jack, the queen and the king of clubs. So they're both clubs and picture cards, and so they're going to go in this area here where the 2 circles intersect. Because we have 3 now in the club circle, that means there's only 10 clubs remaining to go in this section. So this is the section of cards that are clubs but are not picture cards. So they're the cards from the ace up to the 10. There's 12 picture cards to go in here altogether. We have 3 of them here, the 3 clubs. And so there's 9 other picture cards to go into this section. And those 9 picture cards are the 3 picture cards from spades, hearts and diamonds. So if we add 10 and 3 and 9, we get that 22 of our 52 cards have been allocated into the circles. So that leaves 30 cards remaining to go on the outside. So in question 2b part 1, they say that a card is drawn from a pack of 52 cards. Find the probability that the card drawn is the king of clubs. So there is only one king of clubs in a pack, and when we're doing probability is always the number of desirable outcomes over the total number of possible outcomes. So the number of desirable outcomes is 1. There is only one king of clubs. The total possible outcomes when you're picking a card from a pack of cards is 52, so the probability that you'll get the king of clubs is 1 out of 52. 2b part 2 says that a card is drawn from a pack of cards. What's the probability that the card drawn is a club or a picture card? Now there's a number of ways to approach this question. Again, the probability of an event is number of desirable outcomes over the total number of possible outcomes. And we can see from our Venn diagram that 10 plus 3 plus 9, 22 of the cards are either clubs or picture cards. So the probability that it's a club or a picture card is 22 over 52, and we could simplify that by dividing above and below by 2, 11 over 26. Now the other way we could have done this question is that we can see that 30 of the cards are neither clubs nor picture cards. So if we subtracted 30 over 52 from the number 1, well then we get 22 over 52 also, or 11 out of 26. So question 2b part 3 says that 2 cards are drawn from a pack of 52 cards. Find the probability that neither of them is a club or a picture card. So in this question, when we draw a card from a pack of cards, it means that there's less cards left in the pack, and so the probability changes from one selection of a card to the next. On the first selection of the card, the probability that I would select a card that's not a club or a picture card is 30 out of 52. But once I've selected that card, well then only 29 cards are left that are neither club nor picture cards, and only 51 cards remain in the pack. So the probability of drawing neither a club or a picture card on the second selection is different than it would have been in the first selection, and we just have to take account of that. We have one less club or picture card in the pack, and we have one less card in the pack, and so the probability of selecting a club or a picture card on the second go is 29 over 51. In probability, the word "and" generally means multiply, so we want the first card to be neither a club or a picture card, and we want the second card to be neither a club nor a picture card as well. And if we multiply these two probabilities together, we get 0.33.